Guys, welcome back to my channel. We're still going to be continuing with a maths lesson that we started on the 15th of January, which was yesterday. So for anyone who has any questions, please do not hesitate to go to the comment section and put down your questions. If you want to send me a special question so that I can resolve for you, please feel free to go to the comment section and say it out loud. So today we're gonna be focusing on a very interesting topic, number patterns. So we're gonna be continuing with yesterday's paper. Yesterday's grade 12 metric March test for Gauteng. So we're going to be continuing from question 2. So the question says the first 4 terms of a quadratic pattern are as follows. Now they said determine the general term of this pattern. Now, for those of you who might have an idea of what to do, it is going to be very interesting to see how we are going to solve this one. Now, what you can see on question 2.1 is the general term Tn equals an squared plus bn plus c. So basically, they want us to derive the general term for the pattern above. And it's going to be very interesting. So where do we start? Let me write the pattern properly. We have 11, 20, 33, 50, ... Now the first thing to do on a quadratic pattern is to find the first difference. 20 minus 11 will give us 9. 33 minus 20 will give us 13. 50 minus 33, 17. As you can see, the second difference is not constant, and hence this is a quadratic equation. This is a quadratic pattern, sorry. All right. Now, sorry for that. Yes, I was having technical problems. Okay, the second difference, let's see if it's going to be constant or not. 17 minus 13, we're going to get 4. 13 minus 9, again, it's a 4. Yes. We have a constant difference of 4. Now, what do we do with that information? If you go to your textbooks, it has been derived that the second difference is given by 2 times A. Now, what is it that we have? Do we have the second difference? Yes, we do. And the second difference is 4. So if we divide both sides by 2, we're going to get A equals 2. All right. Now, again, if you go to your textbooks, you will find the following. And this doesn't change. If you go to any textbook, that's what they're going to say about the quadratic sequence. Now, they say 3A plus B equals the first difference. Exactly the first difference. You can't take this number. You can't take that number. If you go to my lesson, some of my previous lessons or number patterns, you will see how they derived and come up with all these assumptions. The assumptions like the second difference equals 2A, and this equation of 2A plus B equals the first difference, which is 9. Okay? Given that we have solved for A, it means 3 into 2 plus B equals 9. Now, to solve for B, B will be 9 minus, if you take everything on this side to the other side so that you can solve for B, you will find out that this term will accumulate a minus. If you take it to the other side, accumulate a minus. So it's a minus 3 times 2. 3 times 2 is 6. So it's 9 minus 6, which gives us a good 3. All right. Let's go to question 2.2, which is the last question. Okay. The question says, prove that the sum of the first n differences of this quadratic pattern can be given by Sn equals 2n squared plus 2n. Now, again, if you go to my previous lessons on number patterns, you will see how we derived the sum of the series in different number patterns. All right. What we know is that the first difference is given by 9, 13, and 17. So this is the pattern that we're gonna be dealing with. 9, 13, 17. And the common difference is 4. If you look carefully, we are dealing with an arithmetic pattern or sequence. Therefore, with an arithmetic sequence, all you need is A, which is the first term, which is given by 9. You also need the difference, which is D, which is given by 4. Now, if you go to my notes or my lessons, my previous lessons, we have derived that the sum of an arithmetic sequence is given by this formula as it is. It doesn't change. It does not change. Wherever you go, it is the same formula. If anyone changes this formula, please don't hesitate to come and report it to me. I will see what I'm gonna do to them. But anyways, we have the value of A and we also have the value of D. What we don't have in this equation is the value of N, and that's what we're gonna be solving this equation based on. All right, so what we're gonna have is N over 2 into 2 into times 9 plus N minus 1 times the difference is 4. Now, what we're gonna get is N over 2 into 18 plus N times 4, 4N minus 1 times 4, 4. We're gonna end up with N over 2 into 18 minus 4 will be 14 plus 4N. I don't know if you guys see the same thing that I'm seeing, but I am seeing a common factor of 2. So we're gonna have 2 over N over 2 times, if we take out the common factor of 2, we're gonna be left with, if we take out 2, means if we divide 14 by 2, 14 divided by 2, 7, plus 4n divided by 2, to be 4 divided by 2, is 2n. Then we're gonna end up with the following. 2 cancels, we're gonna be left with n times 7, which is 7n, plus n times 2n. It's gonna give us 2n squared. Now let's go back and see if we have solved what we were looking for. 7n plus 2n squared. Let's see if that's what we got. They said 2n squared plus 7n, which is what we got. Yes. Now, guys, we have come to the end of this lesson, and that's all for today. Now, for those who have not yet subscribed to my channel, please do so that you can get more content as we upload. And for those who want to get more content, don't forget to click the notification button. Or if you want to share with your friends, feel free to do so. I mean, you cannot afford to pass alone this year. This is your year, by the way.